Hello everyone, welcome to our video lecture series on HYSYS and Unitoperation simulations, and this is our lecture 03. The purpose of this lecture 03 is to show you some examples of what we have explained in our video 02, which was use the procedure for estimation of thermodynamic and transfer properties using HYSYS and Unisim. There we have shown the theory and how to do it, and in this lecture video 03 we will show you some examples of what we have explained in video 02. So why not we start right ahead. So we start with problem number 6. We have solved till problem number 5 in our video lecture series 02, and the procedures and the details of all these problems are given in our website, which is Unitoperation.com right here. Okay, so what is the purpose of this particular problem? Here we have to estimate the molar volume. Let's say V in meter cube per kilomole. Of methanol gas. Remember, this time we are going to use methanol gas at 100 atmosphere pressure and 300 degrees Celsius using 3 different equations of state. First is the Peng-Robinson equation of state here, and the second one is using SRK equation of state, so Redlich-Kwong equation of state, and third one is the ideal gas equation of state. So we are going to use 3 different equations of state. This is number 1, and this is number 2, and this is number 3. And the values for this molar volume using these 3 different equations of state are already given here, and we will show you how to find them out using the simulation softwares. So let us go to the Unisim software simulation software right here. As usual, we have started a new case here, and in the view we have to add the compound here. So we write down methanol, which is the compound of interest in this particular case, and we either hit enter or we add pure compound. So we are hitting enter here. So the compound is already chosen. Now we have to find out the equation of state. We go to this fluid package here, and we add, and we go down the list. We select Peng-Robinson equation of state, and we just cross it out. So the compounds are chosen, the fluid package is chosen. So now we enter the simulation environment here. So we go here. Here we right click and drag any stream right here, and then we, by default this one comes, so we just write here methanol. Okay, and here on the composition we give 1.0 because this is pure compound. Once we do that, then this particular window comes in. We have seen all these things before in our video lecture series 1 and 2. So we hit OK here because this is pure methanol. So that's done. So we go to the conditions here, and under the conditions we use 300 degrees Celsius. So that's already given here, and the pressure is 100 atmosphere. We enter 100 atmosphere here. So we have shown you how to do all these things in our last video lecture, that is video 02. So the composition is given, the temperature is given, pressure is given, and as we have explained, we have to give any value in the molar flow rate, although it really does not matter what value we give. And this turns green, that means the stream is completely defined. Now to look into find out the value of the molar volume, we go here and we go to the workbook and we set up, and here let's say we delete this heat flow here, and we add molar volume here. So we go all the way down here and we add molar volume. So that's added. So as you can see, this value already comes, which is 0.3007. And if we can go to our problem sheet here, in the problem sheet you can see that the values what we looked for is 0.3007 using Peng-Robinson equation of state. The next one is we have to use SRK equation of state. We have explained this procedures again in our video lecture series 02, and this is very easy. We hit this beaker here and we go here, we add here SRK equation of state, which is right here, and now we just cross it out. Now in this basis we are now calculating the value of the molar volume using SRK equation of state, which is basis 2. We return to the simulation environment. Do we wish to be left in the holding mode? No. And we go here, you see the molar volume has been calculated 0.3158. So the molar volume according to SRK equation of state is 0.3158, which is we have written down here. And next one is the ideal gas equation of state. That's also very easy. We go here, we go down here, and now we add, for the ideal gas equation of state, we choose this Antoine. So if we do that, so that's pretty much done. So now basis 3 is Antoine, which would be ideal gas equation of state. So we hit here, and now we go to the simulation environment, not to be left in the holding mode. We come back here, and as you can see, the molar volume has been calculated 0.4703, which is according to ideal gas equation of state, which of course is way off, because at such a high pressure, you know, ideal gas equation of state is not really valid. So this value is never to be used. So either you use Peng-Robinson equation of state or SRK equation of state. So that should be good. So that's problem number 1. Let's go to next problem, that is problem number 7. Here the interesting thing is, instead of a pure compound as we have been solving so far, now we have a mixture of compounds. So a following mixture goes to into a water gas shift reactor, and these are hydrogen here, and this is the flow to make hydrogen. No, here to shift to make hydrogen. So basically here carbon monoxide is one compound, steam is another compound, carbon dioxide is another compound, and hydrogen is another compound. So these are the compounds which are already present in the feed mixture. So we have to calculate the molar volume of this mixture of compounds, at 1 atmosphere and 500 Kelvin using SRK equation of state. That is the problem. So here we have a mixture of compound whose compositions is given by this one in terms of molar flow rate, and the temperature is 500 Kelvin and the pressure is 1 atmosphere, and the equation of state we are going to use SRK. So let's try to solve this problem. So we go to our Unisim simulation software. So we start a new compound here. We cross this one out. So we start a new case, and in this view we add the compounds which are already present here. So the very first compound would be carbon monoxide. So we just write here carbon monoxide. As you can see, carbon monoxide is here. We enter, and the next one is carbon dioxide. Now water, steam. So H2O. So the steam that's been added. Next compound is carbon dioxide, CO2, that's been added, and the last one is of course hydrogen. So we need hydrogen, and that is being added. So all the 4 compounds which are present in the feed mixture, they have been entered in the simulation program. So we just cross it out. Next, of course, as usual, we have to use a typical equation of state, and here, so according to the problem statement, we are going to use SRK. So we have chosen SRK here. So now we enter the simulation environment. So let's go here. So we are dragging, right clicking and dragging a stream right here, and let's call this as, name this compound as feed, which is going to the shift reactor. First we define the composition. So in the composition, now we are not going to use mole fraction, we are going to use molar flow rate. So here you hit edit, and here instead of mole fraction, you mole flow. You click on this radio button. Now you enter the values of the molar flow rate of the compounds in terms of the flow rate. So for carbon monoxide it is 630 kilomole per hour. Hit enter, and the next one is steam, that is water, 1130 kilomole per hour. So that's entered. And the next one is carbon dioxide, 189 kilomoles per hour, that is entered. And the last one is hydrogen, 63 kilomoles per hour, so that is entered here. So all these compounds in terms of the molar flow rates have been entered, so we hit OK. So that has been done. Now we are going to use the conditions, and the conditions are 1 atmosphere and 500 Kelvin, which is very easy. So we hit here 500 Kelvin here, and 1 atmosphere pressure. So we hit 1 atmosphere pressure here. So here, and as you can see, all the 4 parameters have been given. So this is automatically defined. So we need to see the molar volume. So we go to the workbook here and go to setup. As we have shown before, we add molar volume. So here we have molar volume, we add, and as you can see the value is 40.97. So let's go to the problem sheet. So we can say that under this condition of 1 atmosphere and 500 Kelvin, this particular feed mixture, this particular feed which is having the composition in terms of the molar flow rates, the value of the molar volume of the mixture is 40.97 meter cube per kilomole. One interesting, let's go to the composition here, and if we click on this composition, you can see the composition in terms of its mole fraction. Although we have entered the molar flow rate values, but in terms of mole fraction, the composition is given right here in this composition. So in the material stream, if we hit, you will see the conditions, and the compositions you can see the mole fraction, and also of course we have found out the value of the molar flow rate. So here therefore we can see we have calculated the value of the molar volume as 40.97. So next, go to our next problem, which is problem number 8. Here we have 25% a mixture. Again we have a mixture here. Again we have a mixture. We have 25% ammonia. This is one compound here, and the rest nitrogen and the hydrogen. So here we have nitrogen and a hydrogen. So 25% ammonia, and this is of course is 75% nitrogen and hydrogen in a 1:3 ratio. So nitrogen in 1 and hydrogen 3. This is in 1:3 ratio. So this is 1:3 ratio. This nitrogen hydrogen is there. So on a 100 kilomole basis, of course, if you do a simple math, so this will be 25 kilomole, and of the 75, of course, if you do 1:3, 18.75 kilomole will be nitrogen, and 56.25 kilomole will be hydrogen. If you add these two up, so that will be of course equal to 75. Okay, so after that it is very easy. We have the pressure as 270 atmosphere pressure and the temperature 550 Kelvin. So for this mixture we have to find out what will be the molar volume, and here we have to calculate molar volume, and of course let's see, we have to use the Peng-Robinson equation of state. So going to the simulation software, we start a new case and we add the compounds. First is ammonia. So ammonia is NH3, that is ammonia, and the rest of course is nitrogen and hydrogen. So we use nitrogen, that's entered, and hydrogen, that's entered. So all the compounds have been added. Next, of course, we have to use the fluid package. We go here and add Peng-Robinson equation of state, which is right here. So that's added. Now we go to simulation environment, and the rest of the part is very easy. So we go here and we right click and drag this material stream here. We just, let's say, name this stream as feed again, and when we define the composition, now in the composition again we have to enter the values in terms of molar flow rate. So we go here, enter this value as ammonia is 25 and enter. Then we have 18.75 kilomole per hour is nitrogen, so we add 18.75 kilomole per hour is nitrogen, and 56.25 kilomole per hour is hydrogen. So these have been added. We click it out. Now we go to the conditions here. The temperature is 550 Kelvin, 550, of course here we have to say Kelvin, and the pressure is 270 atmosphere pressure, which is very high pressure. So we go to 270 atmosphere pressure, and we hit this one right here. As you see, the stream is now defined again just the way before we have done it. We go to the Whirlpool, we go to the setup, and we add molar volume here. And as we have mentioned, you can just put any particular property here. We have molar density, molar enthalpy, molar entropy, molar heat capacity, molar volume. Any value you can calculate. Once these conditions are given, you just add any of these, and automatically you'll be able to calculate or see the values of this particular either thermodynamic properties or the transport properties like viscosity, etc. They will be down here somewhere, like here. So you'd be able to calculate these values. So in this case, we'll be calculating the molar volume. So we go here and click on this one, molar volume add, and you see the value is 0.1771. So let's go to our problem here. As you can see, under this condition of this mixture, that is 25% ammonia and the rest nitrogen and hydrogen in 1:3 ratio, the value of molar volume at 270 atmosphere pressure and 550 Kelvin is 0.1771 meter cube per kilomole. So this pretty much concludes our third lecture series. In the next lecture, we'll be using a pump. We'll be showing how to use a pump in the simulation software. Till then, goodbye. Thank you very much. And just to mention that we are going to come out with a series of lecture series on gate preparation, mainly on thermodynamics and mass transfer. Please look into our website, and we'll keep you posted when those webinar series will be coming up. Thank you. See you till the next video lecture series.